Alright, so I figured I'd do one of those that loops on itself. And if you try to do number 9, if you learn in class for this and try to do it on your own, it's probably going to just turn into a nightmare. But I like them. I think that they actually, I don't know, really get at, do you understand what's going on with the problem? So what we have to do is we got to pick one to be u and we got to pick one to be dv. Now, it really doesn't matter for this particular problem if you pick u to be e to the x or dv to be e to the x. I usually want to pick dv to be something that's easier to do my antiderivatives for, because I don't know about you guys, but whenever I do my antiderivatives, cosines, and sines, I have to think for a second about what should be the sign to those. So let your dv be e to the x in this case. So then du is negative sine of x, and then v is e to the x. So we end up with our uv, so e to the x cosine of x minus v du, uv minus the integral of v du. So e to the x sine of x, it's a negative sine of x, so I'm going to bring that out here. And it doesn't really seem to have gotten any better, right? I no longer have e to the x cosine of x, I have e to the x sine of x. Alright, so if I saw this problem alone by itself, I would probably go, okay, well, u equals sine of x, and then dv equals e to the x. Okay, so then du is cosine of x, and v is e to the x. Okay, fantastic. So let's see what we got. We still have this e to the x cosine of x up front, but now I have a uv, so an e to the x sine of x minus the integral of v du, e to the x cosine of x dx. Now at this point you'd probably go, well, what in the world's going on here? I got this, but we got to keep our eye on what we started with. We started out with e to the x cosine of x dx. Wait a second, got this on both sides of the problem. So at first glance it seems like we're in over our head and nothing's going to happen. But this is an equation. This is all equal to the beginning. So I'm going to add over the integral of e to the x cosine of x dx to both sides. And what we get is 2 integral of e to the x cosine of x dx equal to e to the x cosine of x. Well, actually, it's all this. I'm just going to pull out the e to the x cosine of x so that I don't have to write it again, plus sine of x. And then I still got a plus c somewhere in here, right? So plus c, and then what do I have to do this to? Well, I just got to divide both sides by 2. And I've got my integral of e to the x cosine of x dx equals e to the x over 2 cosine of x plus sine of x, or if you had the e to the x over here, you'd have to have it over 2 as well, plus c. Now, why didn't I divide the c by 2? Well, I could, but a constant divided by 2 is still just a constant. So, loops back on itself. If you ever have a problem where one of the terms is not going to drop out, like an e to the x and a cosine of x, or a cosine of x and a sine of x, and you end up getting the original problem on both sides, the sign will always end up being the opposite, or some sort of fraction. So when you subtract it over, it won't just cancel out. It won't make sense if it cancels out. So you got to be careful of the signs. If this is positive, then you made a mistake. There's our answer.